this case, right? Reduced, I guess I should say, yeah. 0 to 2 minus, reduced. So that's the one there. You might say, well, this one has a 2 minus here, though, and that's a 2 minus there. And I know that, and I get that. But that's not the one, of course, being reduced then, right? Obviously, something has to happen here, because this one is going from a -1 here up to a 0. So this is the one that is losing 1 electron per iodine, or iodide, okay? In total, you only have 1 here. I know we have 2 there. I don't care about that one. We only got 1 here. So in total, this one loses 1 electron, okay? This one here, 0 to a 2 minus, gains 2 electrons per oxygen. In total, so 1 and 4. That's balanced, okay? And you have to do that because, of course, the electrons lost equals electrons gained, okay? After that, I'm going to put a 2 here. That's an easy one. And then this is the one that got a little tricky, if you remember. This is the one where, you know, we got some oxygens, hydrogens over there. We got hydrogens and oxygens over here. How are we going to balance these two things out? And I said to you, don't forget, you can either balance atoms, but also the charges have to balance. So this is a 0, 4 minus. Doesn't matter what I put here, it's going to be 0. Here's a 0. That has to be a 4 minus in order for the left side to equal the right side. Once I do that, of course, I know that I have 4 O's there. I'm going to have 2 O's and then 4 H's, and that balances out. Okay? So that was yesterday's one there. Okay? Next one here. All right, here we go. This one's got fractions, so fractions are our friends. Here we go. Ready? It is under acidic conditions. By the way, do you see any acidic conditions here? H+? There might be a chance where you still have to add some stuff in to balance this out. Okay, so just be aware of that. Let's take a look here. Well, hydrogen is a 1+. Okay, so if I have hydrogen with a 1+, that's an 8+. What does the carbon have to be in order to balance that out? If that's an 8+, what does carbon have to be to cancel that out? 8/3? Maybe. Well, whatever, however you wish to do this, right? But obviously you got an 8 positive. That has to be a negative, first of all, right? Yeah. And the answer is 8/3, negative 8/3. Yes? Negative 8/3 times 3 is a negative 8. Yes? And you got a positive 8, so 0 altogether. Yes? True? Okay. So first of all, think about, when you're thinking about these fractions here, the first thing I would encourage you to do is say, okay, if this is a positive 8, this has to be the negative part. Okay? And then, once again, think about that. I mean, you can set up an equation if you really want to, et cetera, et cetera. If I have positive 8, what does the other thing have to be to give me the opposite of that, of course, right, et cetera. So you can think about that a little bit. This is a 2 negative here, so that's 6 minus. This would have to be a 5 positive to get my -1 charge. This is a 2 minus here, so that's a total of 4 minus. This would have to be a 4 positive. And of course, Mn3+ would be a 3 positive. Okay? So, same thing. Okay? Well, let's see here. What's going down? What's going up here? Well, probably easiest thing, I always look for the one that goes down because that's being reduced, or your oxidizing agent. That's right there. This is being reduced. Mn is going from a 5+ to a 2+. So it is gains 2 electrons per manganese. In total, gains 2. Right? You can see carbon. Carbon goes from a negative 8/3 up to 4. Okay? So it's going up, so this is obviously a reducing agent. Okay? This gains, or sorry, loses, I should say. Can't have two things gaining, that's silly. Loses, well, here we go. How many electrons does it lose? Well, how do you want to do this? Type it in your calculator. You could, I guess. But look, 5 minus 2, or 5 minus 3, I should say, is 2, right? We obviously need to subtract these two numbers, okay, to figure out basically what the difference is. So we're going to take whether you want to do 4 minus 8/3 or negative 8/3 minus 4. It ultimately doesn't matter because you are losing them, right? So you just have to think, I mean, are you ever going to gain a negative electron, or are you ever going to lose negative electrons? No, right? That doesn't make sense. You're not going to lose minus 2 electrons, right? We always write them as positive numbers. So it doesn't matter which way you do this. You do have to find the difference between these two. So if you're going to go, for example, bigger minus smaller, well, 4 minus a negative 8/3, right? Yes? Which is actually 4 plus 8/3. 4, of course. How are we going to solve this? You're going to get a common denominator. Yes? So that's actually 12/3 is 4 plus 8/3 is 20/3 is the difference. Okay? Yes? Yes. This is fun. I told you, Friday, fraction, fun day. Hey? Fraction, friend day, Friday. 20/3. So I lose 20/3 electrons per carbon. Luckily for us, we have 3 carbons. So in total, we actually lose 20 electrons. How about that? I'm going to get rid of this just for right now here because that's going to be in my way there. And if you want to see the math on that, let me know. Okay? So I'm losing 20 electrons there technically, because for each carbon, I'm 20/3 times 3 carbons is 20. Okay? So we need to work this out here. Let's see. 20. So I'm going to multiply this one by 10. Multiply this one by 1. I'm going to put a 1 here and a 10 here. Okay? Yes? Good so far? All right. I'm sure some people are still thinking about fractions. Hey? It's okay. It'll be fine. Hey? 1 and 10. Remember, once you put numbers there, you can't change them. That's set. Okay? Now you're going to balance it based on, well, look, 3 carbons. I'm going to put a 3 there. 3 carbons. I got 10 MNs. I need to put a 10 MNs there. All right? Good. Let's see. What else do I need here? Well, am I done? I don't know. Probably not, right? Because look, I got 3 carbons, 3 carbons. I got 10 MNs, 10 NNs. That's good. But I got 30 oxygens here. I only got 6 oxygens there, right? And we just talked about, well, this is balanced under acidic conditions. So I'm missing some hydrogen ions. I don't have any in this equation. I'm missing some probably water to balance out the O's, right? So look, 30 on this side. I got 6 here, I should say. I don't know what I said. But I got 6 O's here and 30 there. That's a big difference. I'm going to add on this side here, what is that, 6? I'm going to add 24 O's by adding water. Okay? And then on the left side, I need to balance out those H pluses that I added, right? Under acidic conditions, luckily for us, H plus. So I got 48 H's there. Don't forget, you got 8 right there. Okay? So don't forget about those ones. So 48 H's and 8, I'm going to add 40 hydrogens to this side here. Okay? So you may have to add on some water still, and you may have to add in some acid. And if it was under basic conditions, I'd have to add in 40 hydroxides and then 40 hydroxides to the other side. Cancel out the waters then. Okay? So there could be even more to it than that. Good? Questions, anyone? Yes? No? Okay. All right, I guess we should double check to make sure everything balances, eh? So that's 0, 10 minus, and a 40 positive, that's 30 positive. 30 positive, 0, 0, good. I think everything else should balance probably. I'm pretty sure it does because we kind of went through that and added it in the waters where we need to. So I'm sure everything else is good. Okay. Now, last one here. Disproportionation reaction. The OA and the RA is as separate reactants, and then you're going to combine them once the rest of the equation is balanced. So, oh, that's really big. So for the last one here, the OA and the RA are the same thing. That's disproportionation. We know that. Okay. What you're going to have to do here, guys, and you might even want to do this somewhere else. For example, here, I'm not sure, but we need to I'm going to do this, and I'm going to have to do a little bit more work here. So just bear with me here. Okay, so what happens in this case here is we know that the reactant in this case probably, because if you look at the H plus, that's a 1 plus. If you look on the other side, it's going to be a 1 plus and a 1 plus, yeah? I mean, that's pretty much guaranteed, right? So the H plus is not going to be gaining electrons or losing electrons here. So that leaves us with the HS2O3 minus. That's both the OA and the RA is going to be gaining and losing. So the problem with this is, okay, well, that's fine. But how, if this is the OA here, and this is the RA, same one, how am I going to say gains this electrons and loses this electrons, and then have it balance out, okay? So when this happens with oxidation numbers, what we usually want to do, and this is what I would encourage you guys to do right now, is you're going to write this reactant out twice. And there's a reason for that. Trust me, it's going to help you. So you're going to write out HS2O3 minus and HS2O3 minus and H plus gives you S8 and H2O and HSO4 minus. Okay? Because one of these is going to be acting as the OA and the other one is the RA. All right? So trust me, I'll show you how nicely this matches up if you do this. If you don't do this, it's very quite difficult. That doesn't make sense, but it does become very quite difficult to balance this properly. Okay? I said it twice because it was funny. I saw one person smile, so I figured I would go with it. Now I saw 2 people, so 3. All right. So it becomes very quite difficult if you don't do this. So you want to do this, okay? So pick one, it doesn't matter. And you might say, why did you write down, there's only one here. But yeah, I know that. But remember, we got to balance it still. There might turn out to be 10 of them, right? Or 20, or 2. I don't know. But I guarantee you there's probably more than one, okay? Because one's got to gain, one's got to lose. So look, first things first, we're going to go through here, and we're going to put on oxidation numbers, of course. So that's a 2 minus, so that's a 6 minus, 5 minus. This needs to be a 2 positive, correct, to get the -1 charge. Yes? True? Somebody double check me. Okay. Guess what? The best thing about this is you already know the next one because it's the same. Yeah. So look, it's not that much work, right? 1 plus 2 positive, right? Because they're the same thing. 1 positive, we got a 0 here. We got a 2 minus and a 1 positive, a 2 minus and a 1 positive, and now we have what? 8 minus, 7 minus. So that has to be a 6 plus. Is that correct? Somebody double check. Okay. Now, what you're going to do is this, and this is kind of important as well. So we need to look, okay, let's focus on this one here because it comes first, so I'm going to pick this one. Hey, how do I get from here? Look, the H's and the O's, 1 plus, 2 minus, they're not going to change probably. Okay, the O's might, but not in this case. How do I get from 2 positive for that S to 0? Okay, Well, I would say 2 positive to 0. This one is gains 2 electrons per sulfur, right? Because it's based on per atom again for the 199th time, right? 2 plus to 0, that gains 2 electrons per sulfur. I have 2, so gains 4 electrons in total. Okay? Good so far? This is good review regardless. Then I look at my other one. Okay, well, 2 plus here is actually going to 6 plus there. So that one obviously loses. Yeah, well, anyway, we'll get to that in a second. 2 plus to 6 plus, so that one loses 4 electrons per sulfur. In total, loses, there's 2 of them, 8 electrons. And by the way, you should label them as the OA and the RA, okay? So this here would be, let's see, gaining. So this is OA here, and this is your RA here, okay, for that one there. Now, here's why you want to do this. Okay, how do I balance this? Not times 2, times 1, right? So I'm going to put in here 2, let me use a different color here. 2, oops. 2, 1. Okay? The reason I put arrows, so if you did not put the arrows there, please do so. Okay? If you have not put the arrows there, or that little thing that I just did there, somehow do that, however you need to. Because, remember, you might say, well, this gets really confusing because I got, look, these 2 here, and then I got that stuff over there. What I've done by putting the arrows there, I'm saying this one here gains 2 electrons per sulfur to get to this one here. And this one loses 4 per sulfur to get to here. So what I'm saying is this matches up with this, okay? This one here matches up with that. That's where the arrow goes to, so I know that that directly affects that one. So we're going to take that and balance the S8 with it, okay? So, because otherwise, look, is there S's here? There's S's here, there's S's here, there's S's there. How are you going to know if I'm balancing this, how do I know where to balance that to over there? And you won't, unless you match them up, okay? So that's what the arrows do for you. They say this one to this one gains 2 electrons per sulfur, gains a total of 4. So when I balance this, when I look at this one, I'm balancing this one here. So look, I have 4 sulfurs. I got 8 here. Oh. So what do you need to do? Well, you either need to take, now you're going to disagree here, but there's a couple ways you can do this. You can either double this one to get double that, or you can take this and take a half of that. So you can't put a half down. You're going to have to simplify this at some point because, look, you have 2 of these. You're going to have to add them all up eventually, okay? So it's up to you. I don't care. You only got 4 sulfurs here. You have 8 here. So how are you going to balance that out? I know that this one goes to this one, so that's what I'm balancing. If you want to double it now, you can. You may have to reduce a little bit later. That's the only thing. No biggie. No piggy. All right? Or, if you don't want to reduce, you can do this. You can say, okay, well, that's 2. That's 4 there. I'm going to put a half here. A half of S8 is 4. Okay? And I don't know. We might have to go back and double everything later on, or we might have to reduce or whatever. I don't know. Either way, you got probably going to have more work to do regardless. So you're not saving any time, really. Okay? So that's done. That's balanced. I look at this one. This one's got S2 here. This one goes to this one, right? Look. So I need 2 S's there. Okay? So I'm balancing the S's. All right? Good? That's super important. Because if you lose track of where you're going, look how many S's there are on this side, look how many S's there are on that side. You'll never get the right combination unless you keep them straight. Okay? Now, the rest of it, okay, the S's are balanced. You only got hydrogens and oxygens left, and that's, you know, that's where you kind of got to work from. Remember, we put numbers here. I can't change these now, okay? I cannot change these numbers, so I got 6 O's there, and I got 3 more there. That's 9 O's there. Over here, I have 8 already. Yes? And 1 more is 9, and I put the number there because I want to keep that there, okay? Once again, the left side here, I have 2 H's and 1 H. That's 3 H's. I'm going to write that down. 3 H's. On this side here, I have 2 H's and 2 more H's. That's 4 H's there. Okay? So, how many more do I need on this side? I need 1. Okay? Oh, wait a minute. Let's see. No, that's 2 H's, yeah. 1 H, 3 H's, 4 H's, and on this side I got 2, and 2 is 4. Yeah, should be good. Yes? Check the charges, of course. Hopefully these add up. Let's check. 2 minus and a 1 minus, that's a 3 minus, and a 1 positive, that's a 2 minus. And I got a 2 minus here, so it should be good. All right? This is fun. What do you? Hey, I see this. This is fun. It's Friday, fun day, fractions, friends. Hey? Now, we're not done yet though, okay? We're not done because we probably need to simplify this a little bit. Look, we got 2 here and 1 here. We need to get those together, okay? You're not going to see any chemical equation like this. So let's just rewrite this here a little bit here. We're going to do 3 HS2O3 minuses and 1 hydrogen ion gives me a half of an S8 and a water and 2 HSO4 minuses. Okay? Now, some people are going to be like, can you leave it like that? And the answer is, yes, you can. Some people aren't going to be happy about that because there's a fraction involved with the chemical equation. So all I can tell you is this. Okay? Well, can you leave it like this? Absolutely you can. Could this be a possible answer? It sure could be. All right? If it's not this one, it's probably twice as much. Okay? So if you had to find a one that matches up, you might see a 6 and a 2 and a 1 here, of course, and a 2 and a 4 there instead, but same thing. Yes, I hope, right? Either one's acceptable. By the way, if you would have doubled that first one, what you would have got is the bottom one here, 6, 2, 1, 2. What do you think about that? Get that. Write it out twice. That's what you're balancing based on. If you don't do that, you know, because you got sulfurs here and here. By the way, you got more than 4. I guess you got, what, 6. What's the combination going to be here to get 6 sulfurs? And I'll tell you, there's probably quite a few options. And there's only one right one. Okay? It's like balancing. If you don't have, you know, you may have lots and lots of options, and there's only one right one. So these arrows will help you do that, okay? So that you know that this one goes to that, and that one goes to that, and that's the sulfurs that I'm balancing there. And you don't have to worry about the other one, because the other one is from the other one, okay? So, all right.